Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 24-5 Part 2 worksheet. First one here, find the final value of compound interest investment of 4,500 after 3 years at 6% interest calculated annually. So I'm going to use our lovely formula over here. So we are looking for the future value. The present value is what we start with. That's the 4,500. 1 plus our interest rate, which is 6 over 100. Annually means that our k equals 1, so that's times 1, and these two numbers here will always match. And then this is the number of years, which in this case is 3. Okay, we can put this straight into the calculator like it is, but first I like to simplify these here first, because if you don't, sometimes it ends up giving you a bit of a goofy answer. So let's turn this on. I guess it's on. So let's see. We do 4,500. Another 0. There we go. 1 plus 6 divided by 100. All to the third power. Didn't go. There it goes. Okay. We get that, and we get 53, 59, 52. So 53, 59, 57 is our future value. That's how much it'll be worth. Okay? For 3, $2,500 after 6 years with interest calculated semi-annually. So semi-annually means that K is going to be 2, because semi-annually means twice per year. Okay? So future value equals 2,500 times 1 plus 4.8 over 100 times 2, because our K is now 2. Whatever goes here also goes up here. Those are both K's, just like in our formula, times T, which is 6 years. So I'm going to simplify those first. 200, and that's 12. So we plug that into our calculator, and we get 2,500 times 1 plus 4.8 divided by 200, all to the 12th power. Okay, and we get 332307. That is our future value. Okay. And then number 5 here. Find the final value of 8,200 after 2 years, 6.5 per annum with interest calculated quarterly. So quarterly K equals 4. So we get future value equals 8,200 times 1 plus 6.5 over 100. The K is now 4 because it's quarterly, so 4 goes here and a 4 goes there, and then we multiply it by the years, which is 2. Simplify these first, and then plug it into your calculator, and away we go. So we get 8,200 times 1 plus 6.5, not 65. There we go, 6.5 divided by 400, all to the 8th power. And that gives us 932864. Okay, and that is a pretty reasonable answer because you started with 8,000 and grew to 9,300. So you always want to kind of double check to make sure that your answers make good sense, because if this was smaller than 8,200, there'd be a problem, or if it was like $2 million, that would probably also be a problem. So just double check to make sure all your answers make sense. Okay. Moving on to the last two odd ones here. Number 7, calculate the amount that you would have to invest now to have 14,000 in 5 years' time. So investing now, we're trying to figure out what we're investing now. So we're actually now solving for the present value, And this 14,000 is the future value. So we're going to set this up like this. 14,000 equals the present value times 1 plus our rate, which is 4.5 over 100 times k. Compounded yearly is just 1. So there's a 1 there and a 1 there. And this is for 5 years. And that's 4.5, not 4 times 5. Okay. So simplify these first. 100, that's 5. Now look, we have 14,000 equals PV times some number here. So let's do this. We're going to leave the 14,000 alone. We'll leave the PV alone because that's what we're solving for. And then we can actually calculate what this is right here. So we'll clear that out, and we're going to just simply do 1 plus 4.5 divided by 100, all to the 5th power, and this gives us 1.246 dot dot dot, right? So to figure out what the present value is, we need to get rid of this 1.246, so we simply divide both sides by 1.246 dot 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 1.246, and that should tell us what our present value would have to be in order to end up with 14,000. Now on your calculator, make your life easy. Don't get rid of that. We want to take 14,000 and we want to divide by that number. So I'm going to do 14,000 and divide by second answer. And this will work on your scientific calculators too. It's telling us that we got to invest $11,234.31. 11,234.31. So in order to end up with $14,000 in 5 years, you got to invest $11,234.31 now to get that. Okay. Number 9, same type of idea. Calculate how much you have to invest now, the present value, to end up with $65,000. Okay, and then this is, the rest of this is our 1 plus our rate, which is 4.2 over 100 times our k. It says compounded monthly, so that means our k has to equal 12 because 12 monthly is 12 times a year. So we're going to put a 12 here and a 12 here, all times 10. So simplify this first. 12 times 100 is 1200. 12 times 10 is 120. So we bust out our calculator and let's plug this in here. We've got parentheses 1 plus 4.2 divided by 1200, not 12,000, all to the 120th power. And that gives us 1.5208. And that's our present value times that should equal 65,000. So to figure out what the present value would have to be, what we'd have to invest now to end up with $65,000 10 years later, we'd have to divide both sides by 1.5208. 5208 dot dot dot. And so on our calculator, what we want to do to get a really accurate answer is to leave that number there, 65,000 divided by second answer. And that tells us that we need to invest 42,739.37. So that is what our present value would have to be, what you have to invest now to end up with $65,000 in 10 years' time. Okay? Okay, that's all we have for the 24/5 Part 2 worksheet. If you have any questions on this, please feel free to ask. Thanks.